Okay, so in this video, I want to look at one of the cool things that was added to the starter apps on AI Studio, a thing called Video Analyzer. We'll look at it on AI Studio, and then I want to show you having a go reproduce this using code and the new unified SDK in Colab. So first, let's look at what this app can do. This basically will analyze videos for you. First thing you want to do is upload a video. So you can see it's come over here, and then I can just upload a video like this. It will upload it. In this case, it's uploading it to the AI Studio using the files API, which we'll look at later on in code. And then it's going to tokenize it so that we can use it in our prompting, etc. All right, so that's all done. First off, we're going to start off with just the AV captions. So we just click generate over here, and you'll see that it can take a bit of time for doing this. And currently it seems to be limited to videos of not too long. As you can see, I've got a video of about 3 minutes from the Gemini launch in here. But you can see that we've prompted it here with this prompt for each scene in this video. Generate captions that describe the scene along with any spoken text placed in quotation marks. Place each caption into an object sent to time codes. Now, this is actually a function. So you're going to see that it's using a number of functions to do this. So it's not just purely prompting, this is prompting plus function calls. All right, we get this back and we can see that sure enough, it's got all the different things in here. You can see that it's got the text that it started out with. At any point along here, we can just click to go to that and we can see it describe what's on the screen as we're going through this. So you can see here, like an animation of a 3D object that appears to be a window with plants on a dark blue background. That's pretty good. As we watch this, sure enough, that was plants going through it. So you can see, okay, it does a good job at being able to do that. It also captures any speech that's in there so that we can look at, okay, here, what kind of themes does her work explore? So you can see that we've got the text coming out there, but we've also got descriptions of what's actually going on in here, which is really key for this working. So that's the first thing we can do. We can also do something where we ask it to generate like a paragraph response for this. So you can see now the prompt has changed in here. We're still using the same function, but now you can see we've got things back in the form of a sort of paragraph going through describing. And if we look at in here, we can see the actual responses coming back, right? So this is the JSON, and this app is basically just displaying the JSON really nicely in here. So that's for the sort of last one. First one where we had like a full transcript. You can see we've got everything in there with text being what's said to being what comes out, etc. We can probably even play with this a little bit too. We'll look at when we get to doing this with some code. All right, another thing that we can do is we can ask it for the key moments in the video. So now it's going to work out, okay, what does it think were the key moments in this video? Let's see how that's going to display. Okay, so we've got the key moments in the video being more like a summarized version of the first one. So we've got the one at 18-second mark. Okay, that's introducing the Gemini. We've got Project Astra there. We've got Project Astra demonstration. And then it jumps ahead to 2 minutes in, and we can see that, okay, it's summarizing some of the things that Gemini can do in here. All right, we can also do a table. So let's see what this is going to do. Timings, we're getting descriptions, and then we're getting emojis or objects in there. So for the sort of window frame and plants, we've got that in here. The phone displays the sculptures thing. So we've got phone, text, artwork. Okay, a bit of some more unusual one. And then if we look at that one, the interesting thing here was that was using a different function call. So the function call for that was set time codes with objects. Basically was getting out the objects and we're getting it back in this way that we could plot it nicely in a table in here. All right, if we come in here and look at something where we want it to actually do counting, so this is going to be chart this video by number of people. So you can see now the function call is going to be set time codes with numeric values. And we can see that, it's going to generate chart data for this video based on following instructions. For each scene, count the number of people visible. Call the set time codes with numeric values once with the list of data values and time codes. So it'll go through and actually work out each of those things, and then it will call the function call if it's all going to be working properly. And we can see, sure enough, for each of these scenes, how many people is being displayed as we go through this. So we can see, sure enough, that where we've got 3 we can see 3 people on the screen. Where we've got 1, we're just seeing 1 person on the screen. Doesn't look like we've got any times where it's 2, but a lot of times where it's 0 people on the screen. Now, you could imagine that this could be counting a whole bunch of different things in here. We could take this prompt and we could come in and do a custom prompt where we can make it so we count the number of phones on the screen. So let's try running this. Okay, so I've stuffed that prompt a bit too much. Let's see if it's going to work or not. Okay, and come back, and we're now counting the number of phones. And we can see, sure enough, each time the phone is on there, we've now got it counting the number of phones in there. Let's try this one more time for trees, just quickly to see this. And we're going to go through the code for this in Python. So while this one's actually running, let me show you. So Google has released the code for these. So there's a few demos there. The one that we're looking at is this video demo in there. And you can see that they've got the source code there. It's using JavaScript. And if we look at this, we can see, okay, what are some of the key parts about it? We can see that, okay, these are the functions that we're going to need to replicate if we're going to put it into Python. We can see the various prompts that we're going to have. So if we're going to have things like AV captions, key moments prompt, the table prompt, and stuff like that. Okay, this is giving us the prompts out that we'll be able to use for doing these. So from looking at the source code, we can see that, okay, overall, it's not too complicated an app. Now, okay, let's come back and look at our trees before we jump into the code. So no trees. Here it's saying 3 trees, probably more than 3 trees there. Certainly 3 clumps of trees. And it's getting the fact that there are trees in there as well. Right at the end, they're saying there's a tree there. Okay, that's probably not a tree. Anyway, you get the sense of what it could actually be focused in on and doing in this use case. And then lastly, they have things like generate a haiku. And you could really customize this to be sort of anything where you want it to get out certain details for this kind of thing. So you could imagine using this for sort of sports examples, anything like that, where you want it to basically give some kind of visual description or visual analysis of what it's actually got going on there. Okay, so finally it's come back with its haiku, and its haiku for all of this is AI helps us see, hear, plan, and take action to futures here today. Pretty impressive haiku based on this video. So let's jump into the code and look at how we can recreate this with code now. Okay, so I've put together a pretty rough and dirty version of what they did in Python here. And I'm just going to walk through and explain what it does. So first off, you need to use the new unified SDK. So this is just basically bringing this in. And we're going to upload a video. Now, one of the issues that I found with the AI Studio one is it didn't like longer videos for some reason. I think that may be something in the display code. I'm not 100% sure. So I wanted to try this one with a longer video. So this is a longer video. I think it's still under 10 minutes, maybe 8 minutes or something like that. But it's one of the videos that I put up a few weeks ago about Olama and Hugging Face. So first off, get the video, get a path to the video. So I've got the video there. You want to upload the video. When you upload the video, you want to be checking the state, and you'll see that you're often going to be processing. If you set something up like this, you can have it watch the processing for you and then basically tell you when the video is complete, and then the file upload state will be active. That's the key thing that you want to have here. All right, so I've taken their system prompt. So you can see that their system prompt was, when given a video and a query, call the relevant function only once with the appropriate time codes and text for the video. And then the user prompt that they have is a pretty basic one. For each scene in this video, generate captions and describe the scene. And then you can see that they then refer to the function to call in there. So what I've done is, just to start it off, because I haven't set up those functions yet, I basically just took that out and left the rest of the user prompt the same in here. So now when I call Gemini, passing in the user prompt, passing in the system prompt, and passing in the video that we actually uploaded there, you'll see that sure enough, we get a response back. But the response we're getting back is just text in here. So you can see that this is going through and giving us mostly what was said, I think, in here. If we look at it, sometimes there might be some descriptions or something, but it's mostly like a transcript of that. So the next thing we want to do is add the function calls. So there are a few ways to add function calls. In this way, I'm going to basically pass them in as types and function declarations. This allows us just to define them as like a JSON object. So we give them the name, the description. When we're doing it like this, we're not actually passing the function into it. So Gemini won't call the function for us, right? Which is fine in this case, because we kind of want to get that nice JSON formatted stuff out. And then we could call it if we wanted to display it on a UI or something like that. So the main one that they use is this set time codes. And the set time codes basically is going to return back a sort of set of objects where you've got time and text for each of these. And it turns out that this text thing will contain both the sort of transcript and any descriptions about what's going on the page and stuff like that. They have then some other ones that they used in there. I haven't played around with these a lot, but I've just put them in there in case you want to play with them. So this is the set time codes with objects. So if you want to get things back with emojis and stuff like that, you can use that. And you will look at the corresponding prompt for that too, to see that. Then you've got set time codes with numeric values. This is for doing the counting stuff. So where you're basically putting in what it is, the time, and then the number of those things. So like I showed the number of people on screen, etc. After playing around with it, I ended up making a new one, which I'll talk about more at the end. But this is like set time codes with descriptions. And really what I wanted here was to be able to have the time code, the spoken text, and then a visual description for this. So let's see how that goes. But anyway, starting off, we've got the 3 functions that they basically created. And we're going to paste those into make video tools. And I made some little helper functions just for printing these things out. Really, you could play around with this a lot. And this is if you were going to use a UI, if you're going to send it to something else, if you're going to save it to a database, this is where you could put all these things. All right, now, if you'll see that if we're using the prompt, remember that the prompt, we changed it so we didn't have the function being mentioned in there. And sure enough, like even now we're passing the functions in. So we've got these tools equals video tools, which we've just defined up above. But you'll see that when we call it this time, we don't get any sort of function recall response back. We get text. Now we get some text that's got some of what we wanted, but there was no function call. So that's why it didn't show any output there. And that's because we didn't mention the function in the prompt there. If we change the prompt back to putting this mention of this set time codes function in there, suddenly this will work much better. So if we change the user prompt to put the mention of the function back there, the set time codes in there, this will work much better now. So you can see that now when we run it, we're passing in the user prompt with the function call being mentioned. And sure enough, it knows now to call that the function call name is going to be the set time codes. And then if we run that through, that response that we get back through our little function here, we can print these out and we can see them, okay, as they're coming out here. So that now you'll see we're getting not just what I said, but we're getting sort of descriptions of what's on there. You can see like a cartoon drawing of a llama with its hands up appears on the left side of the screen, which is pretty good for describing the Olama logo like that. So anyway, that's gone through and we can see that, okay, that's working. So now we want to put this together so that we can call multiple ones of these. Now, I haven't really played around too much with all of them. I'll let you have a play around with all of them. I have added my AV descriptions one here, that where I'm saying in this one, for each scene in this video, generate spoken text and descriptions that describe the scene along with any spoken text placed in quotation marks. Place each section into an object sent to time codes with set time codes with descriptions in. And this is something that like, I'm certainly not saying that's the best prompt. You can play around with this. You can see now if we basically just pick the analysis mode and pass in haiku, we'll get out the prompt for haiku. Okay, setting up our function calling now as putting it all together kind of thing. I'm going to just check that I've still got the file uploaded. That should be fine, but you never know with Colab if things go down or something like that. The video tools, I'm just adding this new tool in there as well. So we've now got 4 functions that we're declaring and passing in. We've now got everything being processed just like before, except if we know that it's the set time codes thing, we will basically run our set time codes function. If we know it's the set time codes with objects, we will run those, etc. Honestly, I wanted to play with this a lot more and get it nicer, but I'm running out of API calls. So I thought I would just go ahead with. All right, you can see now if we run and we pass in haiku, sure enough, we get our haiku back. Models now abound, quantized versions to choose from, pick the best for you. Okay, that's a nice haiku to describe that video about a llama. We can see the original captions one, the AV captions one, we've got that. And you can see here, this is the one that I made, this AV descriptions, where we're basically using this new function that we've made. And the idea here is that we're going to get out both a visual description, and you can see that sure enough, we're getting a white screen with a faint pattern of code in the background, a black outline of cartoon llama with its hands appears on the left side of the screen. And then we've got the spoken text of what I actually said in there. So this allows us to clearly sort of work out a description of what's going on and have that separate to the actual transcription of what was said in the video in there. You know, you can have a play with this. I think this is a nice way to sort of index videos for putting into any sort of RAG system or anything like that. This is a great way of just taking a video that you've got, putting it up there. You could do some sort of filtering through this nicely, have a nice formatting function, and then even convert these to be text chunks for a RAG so that anytime someone wants to know something about a video, not only are they going to be able to refer to the transcript of what's said, they're also going to be able to RAG over the descriptions of what was actually in the video as you go through. Personally, I will play around with this a lot more and use it for indexing videos, for doing sort of RAG systems as we go through this. It is kind of cool how good the descriptions are of where it describes pop-ups, it describes links to things. So you could imagine using this as metadata in a RAG system is definitely going to be really useful for getting the best results out of this. Now, obviously, when things don't change, so you can see here to here, maybe the screen didn't change, so the visual description just stays the same. So that's kind of cool how you can do this. So anyway, this just shows you how you could reproduce that demo in Python and have a play with it yourself and using for indexing videos and generating both transcripts and visual descriptions out for the video as you go through. Anyway, if you've got any questions, please put them in the comments below. As always, if you found the video useful, please click like and subscribe. I might do some more things like this. If people are interested, please suggest some ideas of what you would like to see. And as always, I will talk to you in the next video. Bye for now.